everyone. I'm Yujin Yang, an astronomer from the KASI, which is Korea Astronomy and Space Science Institute. So I'm today representing our team, and I'm really delighted to share the stories about universe today.
All right, good.
Do you remember when it's the last time and you actually look up the skies?
I don't really think I looked recently.
The only time I would really see it is if I go out to the countryside or the mountains and
We can't really see stars in the city because there's no much reason to look up at the sky at night.
No, I mean, I think we spend more time looking at our screens actually than looking up the sky.
that's true. Yeah.
Yeah, I can totally relate to that because these days the night skies are not really dark anymore, right? And then the world surrounding us actually is too bright, right? So there are so many things to do and so many things to watch, right? I totally understand that there's not many chance to actually look up the skies, but I think that you all know that there's so much more beyond Earth, right?
Yeah.
So what's up there beyond Earth?
Space.
Yeah,
Yes,
exactly.
space.
Yeah. Space or the universe, right? So what comes to your mind when you hear about space or universe?
I think infinite imagination, like Star Wars, Star Trek, all the stuff I enjoyed when I was a kid.
To me, like when I think of space, it sort of feels like the unknown. It's like all dark, kind of like black hole, very mysterious a bit.
When I think of space, I think of SPHEREx first. These days, Elon Musk feel like space to me. Yes.
Yeah, so exactly. The space actually full of imaginations, and that's why from ancient times, people gauge the sky very often. In ancient times, how do you think that people actually know the times and date, and how they know when plant a seed and when they harvest crops?
I feel like maybe they look at the environment a bit, like nature, and then maybe they'll look at sort of like the direction of the wind or maybe the movement of animals. Yeah.
I guess they judge it by how much it's rain.
But in the end, wouldn't they just have looked at the sun or the moon or the stars?
Yeah, pretty close. So at the times, people are trying to track the time and the date. People actually observe skies and track the positions of stars, and then they also observe the movement of the moons and sun relative to the stars, and that's how they find out when they actually harvest crops, for example.
So it's like kind of like science for survival, kind of.
Yeah, exactly.
To survive.
Yeah. Survival science or more very practical, right?
Yeah.
But that was starting. In the end, people get more imagination about the universe, and they start to actually start from the skies from curiosity, right? So here's some quiz about astronomers and the sky. Astronomers look at something. What?
I'm gonna say stars, planets.
Okay, good. Perfect, yeah.
I'd go for the universe.
Universe, okay, yeah.
I think energy.
Energy,
Maybe
okay,
energy
yeah.
outside of Earth. Yeah.
Maybe alien life.
Oh, that's great. Yeah. My intended answer was light. So light is only the medium that astronomers actually can study the universe. And then light is the medium, basically. And then the next question is what would be the tools that collecting this light from the space? Hint is that, who is this person? Yes, Megan?
Galileo?
Yeah,
in English, right?
yeah, exactly, yeah. It's Galileo Galilei, Italian philosopher and scientist, entirely changed the history of the astronomy. What is holding in his hand?
It looks like telescope.
Yeah, exactly. For the first time, he actually used this and looked at the sky through this small telescope. At the time, he observed the crater of the moon and also watched how the shape of the Venus changes. And also, he even looked at the 4 moons around the Jupiter. Okay? That is basically a starting point of something called scientific revolution, right? So since then, whole humanity is transitioned to the point that we are studying universe through the technology, which is telescope. So that's the small telescope, humble beginning. But these days, there are incredible amount of the telescope is orbiting in space. For example, it's a Hubble Space Telescope. And you can see that this huge, powerful telescopes orbiting in the space. The reason that this telescope is orbiting this outside of the Earth is that in Earth has an atmosphere, which is disturbing the function of this telescope. That's why this orbiting. So telescope should be outside of this atmosphere to avoid the disturbance of this atmosphere. So there are very powerful space telescopes such as Hubble Space Telescope and James Webb Telescope. But there are new space telescopes, something called SPHEREx. That's a space telescope launched very recently. And Korea, KASI is contributing to this telescope by the instrument and the mission design and the science cases. So I'd like to invite you to the KASI and meet our colleague and our KASI space science team, how they are doing to understand the origin of the universe.
All right, sounds good.
Questions like how the universe began or whether life exists beyond Earth go beyond simple curiosity. They're long-standing mysteries humanity has sought to solve for generations. A place that observes, analyzes, and imagines to answer these questions. It's the Korea Astronomy and Space Science Institute. From the breath of the sun, the star closest to Earth, to the moon, which is now a hotbed of exploration, they continuously track celestial motions and the evolution of the universe.
지금 보이는 영상들이 우주에서 태양을 24시간 감시하고 있는 것들을 보여주고 있는데요. 24시간 태양을 감시함으로써 지구에 어떤 영향을 미치게 되는지 실시간으로 모니터링하는 것이 되겠습니다.
By monitoring space objects, they also support the National Disaster Response System.
인공위성이나 우주 쓰레기의 위험 또는 소행성과 같은 자연우주 물체들이 지구로 근접할 때의 위험들을 모니터링하는 곳입니다.
In addition to ground-based telescopes that observe light from various wavelengths in space, they also develop space instruments that can withstand extreme environments. But earlier this year, this place drew global attention from the astronomy community.
3, 2, 1, ignition.
The next generation space telescope, SPHEREx, developed jointly by Korea's KASI and the US, was successfully launched, setting a new milestone in space exploration.
Wow, look at that shot. All Merlin engines firing right there, and we have such a great live shot of it.
It's a medium-class NASA mission involving 12 institutions, and Korea is the only non-US country among the core development partners. At the center of it all is Dr. Jong Woong-sop, Korea's lead for the SPHEREx project.
이 우주망원경 미션들은 그 운영부터 시작해서 그다음에 실제 하드웨어 개발, 그다음에 자료를 처리하는 부분, 그다음에 과학 연구 이렇게 크게 다 나눠져 있는데요. 한국은 저희가 기획 단계부터 참여를 했기 때문에 이런 전 과정에 걸쳐서 저희가 참여가 가능했습니다.
This funnel-shaped instrument is SPHEREx, a space telescope designed to observe infrared light, which is difficult to detect from the ground. It's been given a special mission to create the world's first 3D map of the universe. Orbiting Earth, SPHEREx scans a wide area at once, and in just 6 months, it can capture 99% of the observable universe. In fact, Dr. Jong Woong-sop is widely regarded as a pioneer in Korea's space telescope development. While studying at Seoul National University, he joined a Japanese infrared space telescope mission, and after joining KASI, he led Korea's own small-scale space telescope project. In particular, the experience of developing infrared space observation instruments applied to the near-infrared imaging spectrometer for star formation history aboard Korea's first next-generation small satellite, has provided a solid foundation for the success of SPHEREx.
사실 우주 미션에 하나 정도를 평생 해서 과학 연구를 하고 데이터를 얻고 분석하는 작업을 하는 게 하나 미션도 하기가 대단히 어려운 일인데, 저는 운이 좋게도 어떻게 처음에 아카리라고 하는 일본 적외선 우주망원경 미션부터 시작해서 몇 개의 미션을 이제 참여할 수 있는 기회를 갖게 됐는데요. 결과적으로 근데 하나의 이제 키워드가 있었는데 거기서 이제 적외선이라는 키워드는 다 겹쳤습니다. 제가 어떤 방향으로 이걸 적외선을 발전시켜 나가야 될지 그런 부분들을 잘 알 수 있었고요. 더 큰 미션으로 발전할 수 있었습니다.
Korea's NASA-recognized technology doesn't stop here. Dr. Jong and the KASI research team developed a cryogenic vacuum chamber that replicates the negative 220 degrees Celsius space environment here on Earth and delivered it to NASA. Thanks to this, SPHEREx was able to verify and calibrate its optical and spectroscopic performance inside the vacuum chamber without going to space, significantly reducing development time and cost.
외국에서 맡길 경우에 저희가 많은 기술들을 확보할 수 없고, 더더군다나 이거 시간도 훨씬 더 많이 걸릴 거기 때문에 어쩔 수 없이 저희가 이제 국내 업체를 계속 찾아다닐 거예요. 업체가 이제 아주 큰 업체가 아니다 보니까 할 수 있는 부분들이 굉장히 한계가 있었습니다. 그다음에 더더군다나 그 당시 이제 코로나가 있었기 때문에요. 미국은 하드웨어 개발 자체가 코로나 기간 동안 거의 스탑되어 있는 상태였는데요. 저희는 제일 먼저 납품을 해야 되는 하드웨어였기 때문에 그런 부분들이 이제 상당히 힘들었습니다.
After many twists and turns, the vacuum chamber was safely transported to the US. But weather conditions and equipment issues caused the launch to be delayed 8 times. Finally, on the 9th attempt, SPHEREx soared boldly into space.
저희가 거의 10여 년 동안에 기획 단계부터 참여해서 이제 개발도 하고, 그다음에 실제 자료 처리, 그다음에 모든 미션들을 같이 수행을 했었는데요. 결국 그 기간이 많이 생각이 나고요. 최종적인 결실을 이제 보게 된 점에 대해서 대단히 기쁘게 생각을 했습니다.
이제 이렇게 우주망원경을 만들어가지고 우주에 띄웠는데 첫 번째 관측되는 이미지가 사실 완벽하기는 힘들거든요. 근데 이제 SPHERex는 그게 정말 완벽했어요. 다들 이게 정말 첫 번째 이미지라고 믿지를 않았어요. 그 정도로 저희가 예측했던 대로, 그 다음에 저희가 기대했던 성능이 그냥 나왔던 거죠.
SPHEREx has launched into space, but the real scientific research is just beginning. The meeting room is already buzzing early in the morning. The astronomy research team at KASI is now focused on organizing and analyzing the massive stream of observational data coming in from SPHEREx.
관측한 이미지와 이미지 정보에서 얻어진 천체들의 물리적 특성을 분석해서 저희가 각각 천체들의 어떤 거리를 측정을 할 수 있습니다. 그 거리량을 바탕으로 우주 전체 3D 지도를 만드는 것이 이제 저희의 하나의 과학 목표 중에 하나입니다.
The observational data is being shared globally so that anyone can easily access it. This mysterious landscape, woven from thousands of stars, is a vivid image of the universe captured by SPHEREx.
특히 가까운 은하 중에 대마젤란 은하나 소마젤란 은하를 굉장히 깊게 저희가 관측을 할 수 있습니다. 그리고 이제 최근에 지금 아직 공개는 되진 않았는데 안드로메다 은하도 굉장히 아름다운 모습으로 저희가 관측을 했거든요.
The research team doesn't stop at simply releasing observation data. They remove errors and organize the data so that more scientists can immediately use it in their research.
SPHEREx 이미지에서 6개 중에 하나꼴로는 이렇게 넓은 띠가 생기는데 그 띠 때문에 뒤에 있는 은하나 별들이 이제 보이지 않게 되는 경우가 생깁니다. 그래서 저희가 그걸 맡아서 이제 그걸 빼고 없애는 작업을 지금 진행을 하고 있습니다. 전 세계에서 모든 천문학자들이 이 데이터가 나오길 기다리고 있기 때문에 그렇다고 저희가 마냥 천천히 할 수도 없는 일이거든요.
The success of SPHEREx wasn't achieved by scientific and technological advancement alone. It was made possible by the quiet dedication of scientists seeking the origin of the universe. And now, the traces of their relentless pursuit have engraved the name Republic of Korea into the forefront of space exploration.
저희가 처음에 저기서 영상 보강 기술이 정말 가능한지를 먼저 퀘스천을 갖고 시작한 기술이 결과적으로 거의 완성화된 기술로 갔다는 거에 저는 대단히 자부심을 가지고 있고요. 계속 발전하는 미션을 보면서 굉장히 뿌듯하게 생각하고 있습니다.
그동안에는 우리가 선진국에 있는 망원경을 관측을 하고 뭔가 자료가 얻어지면은 그 자료를 갖다가 저희가 사용만 하는 그런 사용자의 입장이었는데 이번 이제 스피엑스 우주망원경 프로젝트를 하게 됨으로써 진짜 우리가 이런 인류 문명, 과학의 진보에 정말 기여를 할 수 있다는 것 자체가 그것이 굉장히 좀 자랑스럽습니다. What do you think about this mission and the space telescope? Yeah.
I just sort of felt the pride and passion within the researchers. And I think probably it's similar for you when, I don't know, like SPHEREx first launch gave you the first signal and you had to also like present the results to NASA. I feel like each and every moment very like touching for you and a very special moment for you too.
Yeah. So exactly, when the spacecraft, the SPHEREx, is separated from this rocket and drifting away from the space, was very touching and it's a very moving moment. And then we felt very relieved that when we finally got the contact of the spacecraft, and we just wow at when we actually saw the first image. These days I'm so busy because of the flood of the data, and then but it's so much fun. Yeah.
You mentioned earlier that the telescope is constantly observing space. So does that mean that we are just being sent images of space in real time right now?
Yeah, exactly. SPHEREx orbiting the space, and it takes the images of universe every 2 minutes. So 2 minutes and 2 minutes, it constantly observing. During the day, it takes about 600 exposure, 600 times. And at each exposure, we got 6 images we gained. So 6 times 600, we got 3,600 images per day. So this huge amount of data. Yeah.
But if it takes 3,600 photos a day, is this too much for astronomy to analyze on their own? Like, do you get any help from AI? Or
Yeah, of course. That exactly. SPHEREx is operating 2 years from now. So it's huge amount of data, and then you cannot handle that with my desktop or even in laptop. So we are using very high performance computing center resources in the US and Korea. But in the end, right now the data is very complex and so brand new data. So right now this analysis needs human intervention, right? So we really take a look at all the images and found interesting stuff. But in the end, as you said, I mean, if we develop enough experience on this data, we will we use AI and machine learning kind of the technique to analyze data because there's too many data. Yeah.
So why does it have to be infrared?
Infrared.
Infrared.
Yeah. So the infrared allow you to actually see the invisible. So visible light is a normal light, which is a usual light you can see in the space. But infrared is beyond that wavelength. If you use infrared, you can see something that you cannot see with normal eyes. And usually the universe is expanding faster. When universe expanding, the light from the early universe expand more. They are redshifted to this infrared wavelength. So if you want to see that really far distance universe, the frontier of the astronomy, you need infrared light. Yeah. That's why astronomers are rely on this new kind of wavelengths.
So if you observe the whole universe for 2 years, does the cosmic map get more detailed or clear at all?
Yeah. So I would say that in the SPHEREx case, we are taking the many universe in many colors. So I would say that our knowledge about universe is more colorful. Right? It's not clear because a small telescope and then our spatial resolution, how can we see the detail, is not really getting better compared to other space telescopes, but it's actually more color, which means that more information, right? So not the red and green and blue, we get the hundreds of the color, so we got more information about the universe. And which sense, then we can actually improve the knowledge of the universe and then also improve the accuracy of the maps.
Have you ever seen aliens?
Okay. Yeah.
So, I mean,
I understand. Yeah, so I got a lot of questions, something like that. Trust me, astronomers are very serious about the aliens or extraterrestrial life. So ET or exoplanet, planet beyond the solar system, also the environment life can live. So we call it Earth 2.0, second Earth, like Pandora in the movie, right? So that's why we are building a lot of telescopes to find this extraterrestrial life or signature of the life in the distant exoplanets.
But doctor, why do you share data from such a high performance equipment with the whole world for free?
Oh.
Like why not you shut it or put restriction on it? Why just make it open? Like is it sensitive information?
Yeah, okay. That's also got a lot of questions like that. Why can monopolize or got money from the data because we invested a lot? But I think that astronomers believe that there's no border on the universe and no one owns the universe, so it's for everyone. So right, if you see the dark skies, that's for everyone, not just any billionaire or millionaires, right? And though on the practical sense, actually we believe that the more the people, astronomers or other publics are working on the data, the more discoveries can be made and very faster. So we release data to expect that a lot of discoveries made quickly hence advance the knowledge of the mankind.
I do understand like the telescope helps us to know more about space and everything beyond, but I'm just curious like does this have anything to do with actual us on Earth? Like, I don't know, can it help with or have a connection with environmental problems or with our humanity in a way?
Yeah. That's one of the questions astronomers address because this is maintained, astronomy is supported by taxpayers' money. That's why the IAU, International Astronomical Union, write actually booklet about how the astronomy is more actually benefit mankind in technology. That include Wi-Fi, for example, MRI or CCDs or other that kind of technologies. But that's a more practical sense. But I like to emphasize that this whole astronomy, this question is about the mankind's fundamental question, basically where I came from, where I'm going. So far as we discussed, humanity started to gaze at the dark skies from the beginning. But now, in the modern world, we are living in the era that actually we can ask some profound questions and we can answer that question using technology and science. So from now on, I will take you to the journey about the SPHEREx telescope and tell you more about the space telescope and the secrets of the universe. So let's go on the journey.
All right.
We are observing entire sky. The SPHEREx is actually can see that basically 150 moon at the same time.
Wow.
You can measure distances and you can make a map of the universe. That's our goal.
What color exactly is space? I mean, is it as colorful as we see in movies?
That's a little complicated.
We do find ice. Does that mean that star can support life?
Do you think that as time progresses, will all these fields of science sort of synergize?
So this is just beginning and there's so much more to be waited to be discovered.